Today, we're going to talk about a family of chemicals that were, absolute game changers. They solved some of the biggest problems that had stumped humanity for ages. But this story of triumph, well, it has a dark twist. It's a tale of how our smartest solutions can sometimes hide some truly devastating consequences. Let's dive in.
It sounds like the start of a really weird joke, right? But the answer connects all of them. It's a single, incredibly powerful family of chemicals that pretty much define the 20th century, saving millions of lives while kinda secretly putting the entire planet at risk. And the answer is a group of chemicals called polyhalogen compounds.
You have to understand, in the worlds of industry and agriculture, these compounds weren't just useful, they were revolutionary. People hailed them as true wonder chemicals because they were solving problems that engineers and scientists had been banging their heads against for decades.
So, what are these things really? Well, it's actually simpler than it sounds. Picture a basic carbon molecule. Now imagine you can just swap out a few of its hydrogen atoms for something a little more reactive, maybe something like chlorine or fluorine. That's it. That's a polyhalogen compound. And that one little change is like giving the molecule a superpower, making it unbelievably stable and versatile.
And because of those unique properties, they became totally essential tools for modern life. These were the invisible workhorses behind countless products and processes that, honestly, we still rely on every single day.
All right, so let's meet our cast of characters. You've got dichloromethane, an incredible solvent. Then there's chloroform, famous for knocking people out for surgery. Carbon tetrachloride, an amazing cleaning agent. And of course, the big one, freons, or CFCs, which completely changed the game for refrigeration. On the surface, each one of these seemed like a perfect miracle.
And this list just shows you how incredibly versatile they were. From stripping paint and powering aerosol cans to making medicines and putting out fires, their uses felt endless. They really were the Swiss Army knife of the chemical industry.
But, and this is a big but, here's where the story takes a really sharp, dark turn. The very same things that made these chemicals so useful also hid a pretty nasty secret, a serious and often devastating toll on our health.
Let's start with chloroform. This stuff was a revolution in medicine. It let doctors perform complex, life-saving surgeries that were just impossible before, all by putting patients safely to sleep. A truly incredible innovation.
But that incredible benefit? It came at a steep price. Breathing in the vapors could mess with your brain, and long-term exposure was found to cause severe damage to the liver and kidneys. Yeah, it wasn't long before doctors started looking for safer alternatives.
And it wasn't just chloroform. Dichloromethane, that master solvent we mentioned, it had its own scary laundry list of problems. Exposure could harm your central nervous system, leading to issues with hearing and vision, dizziness, numbness, and if you got it on you, it could cause intense burns on your skin and even burn the cornea of your eye. Nasty stuff.
Carbon tetrachloride is probably the perfect example of this whole dilemma. On one hand, it was an amazing cleaning fluid and fire extinguisher. Fantastic! But on the other hand, it could cause liver cancer, permanent nerve damage, and in some cases, literally stop your heart. You can see the problem, right? The risks were starting to look a whole lot bigger than the rewards.
The issue, however, wasn't just about direct human contact. Oh no, it gets much bigger. One of these chemical families was creating a crisis on a global scale, a crisis that threatened the very shield that protects all life on our planet.
So, let's talk about freons, also known as CFCs. Look at this list. On paper, they were the perfect chemical. They were super stable, they didn't react with anything, they weren't toxic, they didn't cause rust. For things like refrigeration and air conditioning, you couldn't dream up something better.
And because they seem so perfect, we use them. A lot. By 1974, we were producing about 2 billion pounds of this stuff, globally, every year. Just let that sink in. An absolutely mind-boggling amount of this perfect chemical was being made and eventually leaking out into the air.
So here's the crazy twist. That extreme stability, the very thing that made them so useful, turned out to be their greatest flaw. When freons escaped, they were so stable that nothing stopped them. They'd just float, completely unchanged, all the way up into the stratosphere. But up there, intense UV radiation from the sun would blast them apart. And that kicked off a devastating chain reaction that started chewing holes in our planet's protective ozone layer.
So, a hole in the sky. Why should we care? Well, a weaker ozone layer means more of the sun's harmful UV radiation makes it down to the surface, and that leads directly to some very real problems for us, like higher rates of skin cancer,
eye diseases like cataracts, and it can even weaken our immune systems.
So, if the story of Freon shows us the global price of these chemicals, our last case study really brings the cost home to entire ecosystems. This is the story of DDT, maybe the most famous and controversial polyhalogen compound of them all.
After World War II, DDT was hailed as an absolute hero. It was just shockingly good at killing the insects that spread two of humanity's deadliest diseases, malaria from mosquitoes and typhus from lice. It is no exaggeration to say that this chemical saved millions upon millions of lives.
And this timeline just captures its dramatic rise and fall perfectly. In 1948, its discoverer wins the Nobel Prize. A Nobel Prize, that's how celebrated this was. But then, the cracks start to appear. Insects start becoming resistant, and scientists discover it's incredibly toxic to fish. By 1973, it was banned entirely in the United States.
So what went so wrong? Why was it so bad for the environment? Well, it really boils down to three key problems. First, just like Freon, it's super stable. It just doesn't break down. Second, it's fat-soluble, which means when an animal ingests it, it doesn't get flushed out, it gets stored in their body fat. And that leads to the third problem, bioaccumulation. It just builds up, becoming more and more concentrated as it moves up the food chain, from tiny insects to fish to the birds that eat the fish.
So, when you look back at this whole story, it all comes down to one big question. These chemicals gave us incredible progress, from painless surgery to fighting deadly diseases, but they came with this massive hidden price tag for our health and for our planet. It's just a powerful reminder that every great solution can create a whole new set of problems. And it really makes you wonder, what wonder chemicals are we using today that we'll be telling these same kinds of stories about tomorrow?